Have you ever received a model where the column and walls go from level 1 all the way to the roof? It looks fine until you need to do quantity takeoff, or construction phasing, or 4D simulation. Then you have to sit there and manually recreate every single columns and wall at every single level. It's slow, and if you miss one click, your schedule is wrong. Hello everyone, I'm Clement, and I'm here to show you just how fun and easy it is to create your own Revit plugin using Python, even if you never write a line of code before. Watch this, these wall and column are full of data. I pick them as a source element, or I can select by family and type. I select the level from the dropdown, or just hit select all. The tool auto-detects how many levels each element crossing. I simply click split. Boom! Elements are split by level instantly. And look, the instant parameter from the original element are copied to the new automatically. The tool on the left is my Pro version. It's built with C# and have a modern interface for professional. But today I'm going to teach you how to build the Python version on the right. We are focusing on splitting the geometry. We won't be writing the complex code to rehost door and window today. We are keeping it clean and simple so you can learn the logic without getting overrhymed. We are going to write a script that takes 50 stories, buildings, and slides into perfect level-to-level segment in less than 3 seconds. It sounds complex, but I have done the hard work for you. You don't need to type a single line. I have prepared the Google on my GitHub. Just download, copy, and paste. You have completed the add-in before we even started. The code worked perfectly, but if you are a BIM manager running a business, and you just want a done-for-you installer, with the modern UI and the undo safety net, you can grab the Pro version instantly by supporting me on my website. It saves you hours of setup and keeps this channel alive. But if you want to understand the logic behind the magic, let's look behind the scene. The first thing we need to do here is find out how tall the element is and make a box to mimic it, which is the bounding box. Then we check which level actually cut through that box. Third, we create a new element between each level. And lastly, we delete the original giant element. Let's start with column. Unlike a wall, which is a length and a curve, a column just needs to know where to stand. But here is the secret to making this tool robust. We do not trust the parameter. The column may say it goes from level 1 to the roof, but maybe it has a huge offset, like base offset at level 2 at 0 height, but top offset at level 2 30 meters height. So, on line 142, we grab the bounding box. This asks Revit, regardless of what the parameter said, where does this geometry actually exist in 3D space? We get the physical bottom, which is the minimum set, and the physical top, which is the maximum set. Once we have that physical height, we filter our list of levels. We are asking the code, which of these selected levels actually slide through this specific column? If a level is below the column or above the column, we ignore it. We only care about the intersection. Then, we sort them by elevation. This is critical. We need a clean, ordered list from bottom to top. So now, we have a list that looks like level 1, level 2, level 3, level 4. Now, what we built, we look through that list of level. We take the level at our current index I, let's say level 1, and we use that as a base. Then, we look ahead to the index I plus 1, which is the level 2, and use that as the top. We fit those two levels, along with the original X, Y, and Z point, into the command new family instance. It places a new short column exactly where the old one was, but constrained that perfectly between those two levels. Then, the loop runs again. It takes level 2 as the base, and level 3 as the top. It connects the building back together, segment by segment, using the exact same location point for reference alignment. I also add a little logic check here to see if it is the last segment. Why? Because the very top pieces of the column, the one that hitting the roof, may not stand exactly at the level line. It may have some weird offset. This block of code calculates that specific offset difference, which is the actual top set, to ensure that visually, the new column looks exactly like the old one. And finally, doors.delete. We remove the origin, giant column. If we skip this, we will have duplicate geometry. So create a new segment. Link the constraint, delete the old one. This is the cycle. Now, we move on to the wall. If you look at the script file, you will notice I left the wall section empty with the to-do notes. I left this open because it is a great opportunity for you to practice. However, I know that wall have a few hidden traps. So to ensure you have a reliable reference, I've included a second file called answer.py. If you get stuck, open it up. It contains the complete working code. Now, let's move to the wall part. A column is a point. You just need to know where to start. A wall is a curve. But most importantly, the Wall.Create method does not accept a top constraint or top level. It demands a specific hard-coded height. This is where the most scripts fail. You cannot tell the API go from level 1 to level 2. You have to calculate the distance between them before you calculate the element. Look at line 215 in the answer file. We have to take the elevation of the upper level, subtract the elevation of the lower level, and store that result. Height equal to top minus base. We are feeding the API as a round number, a specific dimension. That is the only way it will listen. Now, look at the creation command itself. Wall.Create. It takes 8 arguments: curve, type, level, height, offset, flip, structure. If you get one of these wrong, you pass a level ID instead of a height double, the script will crash. Let's break down exactly what we are feeding the machine. The first one, the DOS, the active document, which is standard. The curve, this is the path we stored earlier. The API need to know where to draw the line. The third one is the wall type ID. This tells Revit what to build. Is it a generic 200 mm, a brick, or a CMU? We are reusing the ID from the original wall we deleted. The fourth one is the basic level ID. That's easy, but argument 5 is the height. Notice it is not a top level ID. The API signature demands a round number. This is why we did that math calculation on the previous line. We are explicitly telling Revit, extrude this curve upward by exactly 3000 mm. The rest is a cleanup. We set the offset to 0 for a clean split. For the flip, should the wall flip inside out? No. Structure. Is this a load-bearing wall? For now, false. See, it is not scary anymore. It's just a checklist. Path, type, base, height, and a field switch. Once you write this line correctly once, you can use it for the rest of your career. Now we have created wall, but we are not quite finished. It has the correct height, but it isn't connected to the top level yet. If we move the level later, the wall will not follow. So, in the next field line, we fix that. We grab the wall height type parameter, which is API speak for top constraint, and we log it to our top level ID. Now it is marked parametric element. We will do the same last segment checking and delete old giant wall here as mentioned in column part. Today, you build a real-world vertical element splitter, complete with the UI, logic, and Revit API core. You can now slide through massive building in seconds instead of hours. With this tool, you can avoid repetitive modeling tasks and start automating your Revit workflow. No more manual aligning split line at every single level. But I also know many of you are busy fighting deadline, meeting client pressure, or debugging error just trying to set up the Pi Revit. That's exactly why I created the pre-built add-in version, a professional version of everything we built here. You can use it right away with no manual setup, no code error, and no admin write, and experience what this automation feels like when it runs at full speed. It's not just a shortcut, it's a motivator. Once you have tasted what the supported version can do, you will be inspired to learn how it works under the hood. For this tool, I've built it as a modern UI matching Revit ribbon. Split mode you can select by element or by family and type. Undo and redo safety net, and zero setup installer. This green clip now includes all tools from our previous video, and more is coming. For the price of a coffee a month, you help me creating free, high-quality tutorial for everyone, while getting the polished, professional version of your daily work. You can join via my official website. Links are in the description. Every bit of support keeps this channel alive, so together we can make Revit automation easier, faster, and more accessible to everyone. Before you go, what's the next boring task you want to kill? Drop your idea in the comment. Your idea will become the next video. Let's build smarter, not harder. I'm Clement. See you in the next video.